Mission Impossible. We're going to talk a little bit about steep slope stuff. And one thing I want to start with was a video I didn't get to show last time, and this is on a special technique with erosion control blankets and combining that with hydro mulch. And we're going to play this guy so we have that in our toolbox so we can talk about really getting to some steep slopes. So go ahead and start this guy. It's called the Green Armor System. So you might be wondering what we're going to do down here. It's not soil filled, it has been anchored. What are we going to do? Well, we got this chance to do this really cool new technique where Incamat has gotten together with Profile Products, and they've merged the two. They're really neat hydro mulch, which is Flexterra, and we're going to combine Flexterra and Incamat. We're going to put the Incamat down, spray the Flexterra into the interstitial spaces. We're going to put seed and fertilizer and everything you would in your hydro mulch right down into the Incamat. We have a storm front moving in, and it's a good thing that we're spraying this FGM, because this material doesn't really need a curing time. We've installed this material right after a storm and just before another storm on nearly vertical slopes, and we've got it to stick. Remember, we're getting some of our bonding strength from the synthetic fibers bonded together. So we're not just reliant on the bonding strength of the glues. Go ahead and advance a little bit, Adam.
And set up. It's a pretty good mix. Right in there. Little touch up now. Make sure we get our edges too. We can take care of our slopes all at one time. Make sure we get from several different directions here. Make sure we don't have any shadows. Look at the way that's coming out. See the way it feathers out? How's that tank looking? Coming down, we're getting beginning to get a nice dimpled texture in there. Sweet. Good, we've got enough down here, and I want to keep the rest of the material in the tank. So what I'm going to do is shut this off right now. We'll turn the pump off.
About down here, Adam.
We can open up these culverts, and we'll get that water flowing down these channels. This is exciting. It's raining real
you guys
world.
ready?
This is real world, folks. Let's get about a
I
quarter
put 6 inches
tank
of
on here.
DG in the bottom of this
1,500 gallons
ditch,
of water back there in that
just
tank.
so it would erode.
When that's gone, we've got a 4-inch water main coming into it also, and a second 4-inch water main. It's now into our Coir composite. We've got our coconut composite here. Nice application. I don't see any erosion here at all. Don't see any erosion up there. Isn't this great? You actually get to see the channels flow immediately after you've installed the product. We're getting down here to our soil-filled Incamat. Here's our soil-filled TRM. Probably see a little bit of soil loss, and as things settle in here. Yeah. We had a little hydraulic jump right there where the velocity increased. So this is our soil-filled TRM. And now we're getting down to our Green Armor System. This was just sprayed no more than an hour ago. Hasn't even set up or cured yet. Here we go. First time ever. Green Armor System, flowing water, Shasta College facility. Is this great or what? Look at this. A little bit of a high spot there in the middle. Look how important our terminal slot is. So we're starting to get some erosion here. There's a hydraulic jump, and that's why these terminal slots are so important. If there's some channel gullying forming, those gully head cuts are going to start marching upstream, and that terminal slot, that terminal check will stop that erosion from occurring. So that's why those are so important.
All right, thank you. So we're into runoff control, TRMs, and sediment control. I got to working with Caltrans, their landscape architecture group, started looking at advanced sustainable erosion control. They started wanting to deal with these steep slopes. But that meant it's two divisions that don't really talk together. That's the geotech division and bridges and the design, landscape architects, and then design. They're like, you have these divisions. They don't talk, they don't communicate. And yet we've got to address this problem because these are the most expensive items that work we're doing. We have a lot of steep land like you do here. And so we had to start talking about ways, and we want to get that 70% cover. How do you get a 70% cover on a one-to-one slope? You know, you have the same problem here. How do you do that? And yet we've still got to do it because we've got to get signed off on our notice of termination. And you know, because if we don't, until that thing's done, we're submitting papers and inspecting, and dollars are going way up. And so what do we define as a steep slope? And we kind of define everything above 2-to-1 as a steep slope. And I don't know if you you have slope stability issues at 1-to-1, certainly. At 1-to-1, and as you're having vegetation established, it's really hard to get veg to grow steeper than 1-to-1. Maybe 1.5-to-1 you can get some veg to grow. And then erosion and sedimentation are the problems at 2-to-1. But slope stability are here at steeper, but yet at 2-to-1, the geotech engineers are saying that's our purview, that's our problem. Well, not really, you know, if that's where we're going to try to get vegetation established, you don't want to come out at everyone. And if you go to a geotech engineer and you ask them over and over and over again, what's the angle of repose, what's the factor of safety, they're going to tell you really it's 2-to-1. Soils of most types stand on their own at 2-to-1. You dump a gravel truck out of the, and you're going to have an angle of 2-to-1. And so if you look at here, sand, dry material, it's about 2-to-1. Sand, wet material, 1-to-1 because it gets wet and it kind of settles. And water filled, of course, it liquefies, it just goes whoosh out. Shale, 2-to-1. Clay, 2-to-1. Clay wet, excavate, of course, that could pooch out. And granite, 2-to-1. So we're talking 2-to-1, things are standing there. Why are we calling on a geotech engineer who's got a lot of important work to do? Why call on them on a 3-to-1 or a 4-to-1? So the thing is, 2-to-1 steep, anything steeper than 1.5-to-1 or so, we should probably consult with them. Or better yet, what if we came up with some ideas that even landscape architects could agree on, is reinforced soils, reinforced slopes. At 1.5-to-1, 2-to-1, let's reinforce it some way. And these are the kinds of slopes we're working on, failures and stuff, and a couple of different longitudinal type failures and block slope failures. Another little tool I wanted to give you, I didn't get to give you in the last time, was the use of berm. This is it's a little aside, I'm sorry about that, but I've been pushing compost to be used for a long time, and we did this training. I told you 400 people came, and you know who didn't come to that, of the 400 trainings and thousands of employees of Caltrans that came, you know how many who didn't come? Was the resident engineers. They didn't show up. Out of thousands of people, we had a handful of resident engineers came over this 9-year period. So in Windsor, where it's wine country, there was a project on Highway 101 that was going for 2 years. And the game warden was getting really frustrated with the contractor. And he went down there, as he had the right to do, and he handcuffed the contractor and the resident engineer. And 3 days later, David Franklin and I were meeting in Oakland, giving one of our last trainings on one of these, and they've been showing up, 40 people had been showing up. Then lately there'd been something like 15 or 7. We saturated the market. All of a sudden there's 65 people show up that day. Most of them were resident engineers. They got word that they could be in trouble because they run the job, right? Those are the guys that run the job. They say yes or no on this stuff. And so right away they put what can work on this project? They put instead of the silt fence, the compost berm. Compost berms are so cool. They put them down by machine. You put guar gum, remember that guar chewing gum material in it, and you build like a curb machine. And that's all you need. You don't need a compost sock or anything. This is a compost berm up in the Canadian Rockies, one that we put on there, and after we pulled the compost berm up, you can see the roots that grow through it. Alternative to silt fence that grows grasses that you don't have to go retrieve. Compost berm. Okay,
look at this, that 700 cubic yard site, and then we put a compost sock or a compost berm at the toe of it. And I'm making a movie called The Big Cover Up, and we're gonna show compost. It's gonna be one of these Dirt Time movies. And I used this berm machine and built a compost berm at the toe of this slope. Anyway, I built a berm at the toe of the slope as I'm filming the movie. So what I want you to watch here is, this is our little mountain we built. There's some tire tracks right here where one of my students drove on the wet slope, and they run down here. But otherwise, this is 2 inches thick of compost. I didn't put any tackifier in it or anything. It's a 1-to-1 slope. And here are the little compost berms. And what happened was, we got that weekend, 3 days later, we got 8 inches of rain in 4 hours. I've never had anything like that. And it was 4 inches in an hour. I measured it. I ran down to the stream by my house, and this is what the urban streams were running. 2 people died in Redding on that storm event, the urban stream we were working at. And then the next day I went to the college and looked what happened, and the compost berms, look at that. Because they were such a small drainage area, and that's what you want to do with silt fences, make a small drainage area for your embankment. They held everything back. We put some ryegrass in, so after 24 days you could kind of see what happened. But that material, the only place it gullied was right there where that kid's tire track had concentrated the water. So compost can stand at 1-to-1, 2 inches thick, and withstand really high flows. And wood chips can't do that. Okay, so we've got a couple of best management practices I want to get to for this. Our RECP, rolled erosion control product wraps, flaps, brush layering, step slopes, and rock slope protection. And to tell you a little bit more about that, the material we're going to use to wrap is coir netting. We've got biaxial geogrids. You're all familiar with those. And so they're made out of polypropylene. And then we have the biodegradable stuff that is coir netting. This one is 400 grams per meter, looks an awful lot like jute netting. You familiar with that one? That's coconut. It lasts about 4 years. It would last 4 or 5 years here in Hawaii. The other one is 7 grams per meter. That's got openings about an inch, 3/4 of an inch. It's moderately durable. It would last about 6 years. And then the 900 grams per meter is tightly woven coir netting. You can actually put that in channels. And this is the one we're using on our steep slopes, because we can't use, we're not allowed by Fish and Game to use a lot of polypropylene on our slopes. We can bury the geogrids. So the one is called a flap or a wrap. You wrap and reinforce this. In the drawings, it's really easy to make it look like a 1-to-1 vertical, a 1-to-1 smooth, uniform site, and wrap it around. But to really build it like that is darn near impossible. And it slumps down into a catenary curve, which my geotech engineering friend Donald Gray says that's the strongest angle anyway. It's like taking a chain and holding it. It'll form a catenary curve, and all the links will be under equal pressure. And then you put a bridge across that, and it'll have a parabolic curve. So these were really difficult to build using, and they're wrapped, the face of them are wrapped with geogrid. And here's the way they actually look. And these drawings are from Dirt Time. We did a county road up in Santa Cruz. Here's some geogrid on Highway 330 to Big Bear, Southern California. ECB wrap this was a huge landslide. It took out this little yellow frog, which is critical habitat. It's the one bad or extremely endangered species in Southern California. It closed down the highway for a month. So the storm drains plugged up on the highway, this decomposed ground, it blew up, and they had to build gabion hill fiker walls. But down in the bottom, they hired me where there's a creek that had been impacted, and they were able to remove 15,000, there were 60,000 yards. They were able to remove 15, and they had to pull it out with a motor, with a loader 5 yards at a time. They were able to get 15,000 yards out. But I was able to go into the stream bank and reshape it and bury it back in there and make the bank out of it. So I'll show you where the wraps come in. I did willow planting and took some rock down there and then build these terraces out of the fill. Remember, I've got 20,000 yards to lose. I reshaped the channel, put rock in the bottom, and then built the flap. So we're rolling the fabric out and then we'll flap it down and then anchor it. So much easier to build. And then we put in our willow for brush layering and GeoGrid. And here it is. So GeoGrid, willow branches, then netting, flap it down. Build your next lift, and it's so constructible it's silly. And so you have a slope now, and you don't have to worry about anchoring the blanket because half the blanket's anchored by gravity back in here on the terrace, and then you anchor the face of it. And that also reinforces the slope. Remember, anything steeper than 2 to 1 is going to need reinforcement. So that's a tool. Then another one is brush layering. You won't worry about that here. I don't think you have things like willow that grow. You might have, but the reinforcement is the willow branches, and then they actually grow. They're good because hydrostatic pressure builds up on these slopes, and they will actually relieve hydrostatic pressure. Even if you compact the fill really well, there's going to be pore pressure building up in places. Like we found out on this place, 91, I built the fill slope up on Buckhorn. And then here's the flapping method again, RECP flap. And we did a study here, and then they allowed us, they were doing a UC Davis study to see how much compost, if we were to mix compost with soil to increase infiltration rates and still bond the soil, what would be the best amount? We found that you could get roots of 4 feet, infiltration rates of almost 2 inches per hour, and if you mix 25% compost with your native soil. So that's, again, for your bioswales, that's a good mix. So we were able to use our compost mix, and we built this slope up. We worked our way back out, did brush layering, did soil flapping. There's the flapping method. There's the finished slope. Mixing 25%. We're not even attempting to compact the face. How's that? But yet, just dozer packing it, just walking the dozer, and it's at kind of optimum moisture. We had a tensiometer, or trying to think of that machine that measures compaction. Anyway, nuclear compacting tester. Anyway, we got around 89 to 92% compaction. There's the lift going down, the flap, a little belt like here, like a beer belly is going to form a little bit like that. That's the catenary curve. There it is. I need a belt for my beer belly. Catenary curve is the perfect belly for a pregnant woman. That's where all the skin is all under equal pressure. And it's good for a beer belly for a man, and that's where you want to be. That's nature's way. And so this is going to curve a little bit when it's all settled. And there we got perfect compaction. Ed liked it. Got a big storm right away. Nothing failed. First time our erosion control hasn't failed up on Buckhorn Summit. There it is after. And then Caltrans went after $11 million to realign this highway. They went back cutting it 1-to-1, and there's failures like crazy, and anyway, it's been hundreds of thousands of dollars of fines. And then this takes me back to Santa Cruz. This is my brother's house. It was being foreclosed on. It's near my surf spot. It's been in the family via my brother for almost 30 years. My mom, when she passed, we spread her ashes on the beach right there. It's called Sharks Cove. And on the weekends, we would go down and hire a pumping truck. There was caves on this Prisma. There's a sandstone formation and then a marine terrace deposit. And the sandstone had eroded these cavitation caves. And we'd sneak down with no permits and do illegal pours of concrete into it because it's impossible to get permits. And you can see we're standing on this, guys. And I was doing landscape contracting in that neighborhood, and my brother kept saying, John, fix my house, fix my house. My grandkids are there, so I twist my arm to go to Santa Cruz, and that's where I grew up surfing. And so Grayson and Kelly and Molly, and they went there with me. I'd worked on this house next door, built a cantilever deck out over it, and we'd actually filled up the sea cave, but this is a nice recurve. This was a engineered approved wall. When the water waves hit it, they throw out over and the waves come back into the ocean. Instead of, we found that waves that just ride up the wall and then come down, they take a lot of the beach with it when they're going back out. So that's where the erosion is. So if you can get a curve to throw it back out over the ocean, that was the key. And some kind of weird grass growing. So looking north along the coast, and my brother's under foreclosure now, and he says, John, I can't sell the house with this thing hanging out there. And I said, no, I must not. So I know what I know about Incamat by now. I know what I know about Green Armor System. So we shaved a little bit of that, shaved it back. My brother was right there. He goes, that's worth $1,000 a foot. Don't shave that stuff too much. And we put the Incamat down. And we anchored the Incamat with all sorts of different anchors. I got this marine terrace deposit. It's sandy some places, it's clay, it's got seeps in it. It's just a melange, a mess. And Alex is down there anchoring, and we're dropping the Incamat down and anchoring it like this. Big, sometimes 80 penny nails with a big washer. That'll be the one we have to use there. And then the Passmeyer's house down there, how come that cliff didn't fail? I've been working on these houses for 30 years, and I remember that's a willow bush. And down by the yacht harbor is another willow bush that's been there for 60 years. I'm 69 now, and that stuff's been there. So we took those willows, and those have been climatized or evolved to withstand the salty conditions, and we put the willows down there while Alex napped. And we drove them down at the seeping zone. And then we got our machine, and we used the Flexterra, the Green Armor System. Taught Alex how to shoot it right into the interstitial spaces. The thing I blew is I didn't get a soils test. And I got a marine mix that's native marine grasses. But if I'd gotten a soil test, I think I would have found that was sodic, very high sodium salt. And it didn't, the veg didn't grow very well. And so you can see when we were done. And then in the first month, it got 7 inches of rain. In the first month, 7 inches of rain, nothing failed. You can see it stick out there. There's my one neighbor, and there's the other neighbor, and there's my brother's, his house set way back. There's his wall. 2009, after 1 year, still no erosion, but not a lot of veg either. After the next year, in fact, the neighbors, there's my brother's house, one of the neighbors, this thing failed 60 feet in one storm event, one catastrophic event. I won't say it's a storm, the block failure. And the willows are still growing slowly down there, and everything's looking good. Farther up the cliff, because it's like Waikiki, it's like our ocean access, Surfing USA. And so they're going to take and do pinning of the gunite and shape the gunite and stuff the rest of the cliff, make it look natural. And you all know O'Neill's, right? That's Jack O'Neill. Yeah, I grew up with Jack O'Neill and his kids. O'Neill wetsuits and stuff. So there's Jack. He's got the only house on the beach side. He's on the beach side, and they took this. So I'm thinking this is like what I'm doing with the Green Armor System is like the $1,000 repair, and this is the $1 million repair, because they're shaping it and dyeing it, and you can see the color of it. They make the cliff, look at it, looks pretty natural, huh? That's all gunite. So there we go. There's more on dirttime.tv. There's an archive of books, and there's some other books that I've written on bioengineering and stuff. So root architecture is some of the stability that we get now. Don Gray was a geotech engineer at University of Michigan, and Don Gray had his students, we could measure the tensile strength of a piece of rebar, and he wrote one of the first bioengineering books. But if you take a hair off my head and we measure the tensile strength of that hair, and then it'll have some tensile strength. And if this is the failure plane, and we put a bunch of my hair in that failure plane, we're adding the tensile strength of my hair to that slope, and we're adding the slope stability. And just like we're adding a willow stake or a willow root, every one of those roots has tensile strength. That's nature's way of bringing slope stability about. And so every one of these kinds of roots has different attributes. This particular one is a native grass. It's only 5 months old. And look at the roots in it already. It's one of those fibrous roots, got really a lot of pull-out resistance. And you can see willow roots here. There's my sunglasses. This stake that my students put in is only 9 weeks old. It's got 200 feet of root already. And I'm up on the bluffs right now above. I live down in there, the Sacramento River, vertical bluffs, homeowners association. They've got a tree that had fallen over, irrigation system that had failed. And we're going to do VMSE, vegetative mechanically stabilized earth. And I look down slope, and there is a willow bush, and it's holding back 3 feet. So willows would be appropriate. They're native, they're holding back that slope. And I'm going to lay back, I'm going to build out a wall 3 feet on a vertical wall without going, the river's 200 feet down. How do you build a geotech wall when I can't go down to the bottom and anchor? I'm only going to go down 25 feet. So I want that, and I've got to move it out. I want that fill to be kind of light. I've got to build it out 3 feet. And I thought of the idea of the Filtrex socks. So I got the Filtrex socks. You might want to watch this, Matt. So I got the Filtrex socks and started laying them out across the slope. And I also used some grow socks. So right at the very toe, I found kind of a deer trail. And I used GeoGrid, and I used Coir logs and Coir blocks. And I used these anchor systems, duckbill anchors, with a driver. It's got 550 pounds torque on them for pull-out resistance. And then I started laying those in with brush layering, willows. And then I would stagger the grow socks. The black socks have compost medium, and these have more of a filtering compost medium. And they're stronger. And so it's kind of an unusual kind of use. But all of this had to be built by wheelbarrow and by hand. And so as we're building our lift up, and then I decided as we got up here, I'm going to plant those same Elymus glaucus plugs. Remember that five-week-old one? And I'm planting the Elymus plugs into the grow socks. And they have a mycorrhizae relationship with the fungi that sends out hyphae to go chase nutrients for it. That's how California native grasses live for 7 months in the summer with no irrigation and no rain. So we're working our way up the slope, and boom, got it done. You can see how far down it is. And then this last winter, it cracked and settled right in here at the top lift. Ends up the top lift, that was one of their irrigation lines. They swore the lines didn't leak, but there was soil piping. And I dug it finally out, and I said, look, here's your irrigation lines. I found the leaks, fixed a couple of leaks, plus there was soil piping from up on their irrigated lawn. And we pulled that thing back just last week, and I got it back, and instead of showing you the last picture, I've been riding my e-bike, my electric bike around, and looking for an erosion for you all, so I didn't take any pictures of the last day. And that's about all I got to say about steep slopes. Any questions?